Now let's see the various notations for a circle. Now that we have seen the equation of a circle in general form, now we have notations through which we understand the circle in various ways. So for example, the general equation of a circle is taken as x squared plus y squared plus 2gx plus 2fy plus c equal to 0. And this equation, which is the general form of representing equation of circle, is usually denoted with s identically equal to this. So this is the notation. When I say s equal to 0, it is understood as the general equation of circle x squared plus y squared plus 2gx plus 2fy plus c equal to 0. So from this, we have various other notations. Say if I just wanted to have S1, the S1 is generally denoted by x1 plus y1 plus g times of x plus x1 plus f times of y plus y1 plus c equal to 0. So this is how we denote for S1. And remember here, x1, y1 is a point. For the point x1 comma y1, we have S1 equals this. Say for example, if I wanted to find S2, then in this case I have x2 plus y2 plus g times of x plus x2 plus f times y plus y2 plus c equal to 0. This is for the corresponding point x2 comma y2 through which I have S2. Therefore, if I have, say, a general point xi, yi, then in this case my si would simply be xxi plus yyi and so on and so forth. So therefore my si is xxi plus yyi plus g times of x plus xi plus f times of y plus yi plus c equal to 0. This is how we represent for the point xi, yi. For the point p xi, yi, I have si is xxi plus yyi g times plus f times plus c equal to 0, where I is anything running from 1, 2, 3, so on and so forth till n. This is how we understand the notation for SI, S1, S2, so on and so forth till SI for the general equation of circle S equal to 0. Now we have the other types of notations. Say if I have the points x1, y1 and x2, y2 as 2 points for the circle, then my S11 or S12 is defined as x1, x2 plus y1, y2 plus g times of x plus x1 plus f times of y plus x1 plus x2 plus f times y1 plus y2 plus c equal to 0 is how we define for S12. Similarly, if I wanted to find S11, then this would be x1 squared plus y1 squared plus 2gx1 2fy1 plus c equal to 0. And S22 is nothing but x2 squared. It is nothing but substituting of x2 and y2 in place of x and y, plus y2 squared plus 2gx2 2fy2 plus c equal to 0. That's how I just have for the given equation. So this is how we have various notations for S1, S2, Si, S11, S12, S22, etc. So these are the various types of notations which we need to understand, because when we come across many topics in the future, we need to utilize these formulae in application of various concepts. Now let's take an example problem to understand the notations more better. Say for example, I have a problem where I had to find S1 with respect to the point minus 2, 3 for the circle x squared plus y squared plus 2x minus 3y plus 1 equal to 0. So for this circle with the equation given out here, I need to find S1, where the only information given out here is the point minus 2, 3. So now that we have seen the notation, let's initially take the circle denoted in general form as S. As we all know that general equation of circle is represented by S equals x squared plus y squared plus 2x minus 3y plus 1 equal to 0. So in this case, my point here is minus 2, 3, where my x coordinate is denoted by x1 and this corresponds to y1. So with this basic x coordinate being x1 and y coordinate being y1, my S1 is nothing but xx1 plus yy1 plus 1 times of x plus x1, because 2g reduces to g, as we can see. Now g is 1, so 1 times of x plus x1, and this reduces to 3 by 2 of y plus y1 plus 1 equals 0. So it is very important that 2g becomes g and 2f becomes f, that is half of the coefficient of y and half of the coefficient of x, which comes out here. So half of coefficient of x, which is 2, is 1, so 1 comes here, and half of coefficient of y, which is minus 3 by 2, comes out here, which is a very important note when we simplify for S1. G times of x plus x1 plus f times of y plus y1, this being 2g and 2f of x and y respectively. So in this case, my x1 is minus 2 and my y1 is 3, which I substitute in this. So therefore, I get this to be x1 plus y1 plus x plus x1 minus 3 by 2 of y plus y1 plus 1 equals 0 is what we get out here. Now this, on further simplification, gives S1 equals minus 2x plus 3y plus x minus 2 and plus minus 3y by 2 and minus 9 by 2 plus 1. Now this, on further simplification with simplification of x terms, gives us minus 2x plus x is minus x, and 3y minus 3y by 2 is 6y minus 3y. So this is plus 3y by 2, and this is minus 2 plus 1, which is minus 1, and minus 11 by 2. So therefore, this is the required value of S1. So as we can clearly see that the circle, which is a second degree equation, reduces to a linear equation, that is S1. So we can see that clearly S1 is a straight line. So I had to make an important note here that S1 equal to 0 is a linear equation or a straight line for the circle S equal to 0 with respect to the point x1 comma y1 is what we conclude. S1 equal to 0 is a linear equation or a straight line for the circle S equal to 0. So this helps us in understanding that. So any line considered for a circle has some properties connected with s equal to 0 and s1 equal to 0, which we are going to see in the future topics. So therefore, with the various notations, I understand that s equal to 0 is the equation of circle and it is of degree 2 or second degree polynomial. Now when I take s1, as we have seen in the previous case, it is a linear equation with degree equal to 1. And when I take s11 equal to 0 or s12 equal to 0, this come under constant term because they give a constant value when you simplify. Gives a constant term whose degree is equal to 0 and etc. is how we understand the learning outcome of the notations s1, s2 or and s2 equal to 0 with all these notations. S1 and S2 are linear equations with degree equal to 1, which is a straight line, and S11 and S12 equal to 0 are constant terms with degree equal to 0. Is how we understand each of this. This is a circle, these two are linear equations, and these two are constant values. Now let's see the position of a point with respect to a circle. Now when I discuss about position of a point, there are three different cases through which we understand the position of a point. The three different cases are that a point can lie inside the circle or on the circle and outside the circle. That is, if I take the three possibilities, one is if this is a circle, the point, if this is the circle s equal to 0, then if the possibility is that the point x1, y1 may lie inside the circle. And next, the second possibility is that for a circle s equal to 0, the point p x1, y1 lies on the circle. And the third possibility is that the point P lies outside the circle, s equal to 0. So these are the three cases where a point P lies inside or on the circle or outside the circle. Is how we understand three different cases of position of a point. Now when the position of a point is inside the circle, we say that S11 is less than 0. The property is that when P lies inside, S11 is less than 0. Now when P lies on the circle, we say S11 is equal to 0. And when P lies outside the circle, we say that S11 is greater than 0 for this case. So in each of the cases where P is inside the circle, s equal to 0, then S11 will be negative value. When P is on the circle, S11 is strictly 0. If P is outside the circle, then S11 is strictly positive. Therefore, if I give a point and a circle, if I want to know the position of a point, I can just find the sign of S11, and the sign of S11 will decide the position of the point, whether inside the circle or outside the circle or on the circle. Now let's see an example problem to understand the concept more better for finding the position of a point with respect to the circle. So for example, I have a problem which says find the position of the point 1, 2 with respect to the circle x square plus y square plus 6x plus 8y minus 96 equal to 0. Now I have a point 1, 2 and have a circle this. Now I want to find the position of this with respect to the circle. That is, I want to find whether this point lies inside the circle or on the circle or outside the circle. Therefore, it is very essential that I find S11 and then the sign of S11 will decide whether the point lies inside, on or outside the circle. So let's see how we can find for this realistic problem. Now the equation of circle, which we denote with S for the general form, is given as x squared plus y squared plus 6x plus 8y minus 96 equal to 0. And the point is P1, 2, where this is x1 and this is y1. Now for finding the position of the point 1, 2, let me find S11. Now we know that S11 is x1 squared plus y1 squared plus 6x1 plus 8y1 minus 96. So I need to find S11 by substituting here. So this on simplification gives 1 plus 4 plus 6 plus 16 minus 96. So 10, 27 minus 96, that is minus 69. As I clearly see that my S11 is negative value, that is minus 69, therefore S11 equal to minus 69 is less than 0, that is negative. And therefore this decides that for a negative value P lies inside the circle, is interior point. Therefore P1, 2 lies inside, or it is interior point lies inside the circle S equal to 0, is how we conclude. The negative value for S11 decides that the point lies inside the circle. So anytime we find the position, we just find S11 and the sign of S11 will decide for a point lying inside, on or outside the circle. Position of a point with respect to a circle. Now let's discuss the power of a point with respect to the circle. Now power of a point Px1 y1 with respect to the circle S equal to 0 is said to be S11. So power of a point is said to be S11. Now this is very much connected with the position of a point, because position of a point is decided by power of a point. That is, if the power of a point is positive, then the point lies outside the circle. If the power of a point is negative, the point lies inside the circle. If the power of a point is 0, then the point lies on the circle. It is through its power that we decide the point lying inside, on or outside. Power of a point with respect to circle S equal to 0 is S11. Now let's discuss about the most important concept of a circle, that is the tangent. Let's see initially on how a tangent is derived for a circle. Now let's define the tangent for a circle. What is a tangent? Now that we have discussed about secant, let's recap with the secant definition of a circle. Now we have seen that if there is a circle and there is a secant which cuts the circle at P and Q. We know that PQ is the chord and the whole of line PQ is the secant. Now this secant, if as I go towards the circumference of circle, that means as I go towards down, I clearly see that the lengths decrease. The distance between P and Q starts reducing until both P and Q unite to become one unique point. That means as this line moves downwards of the circle, we have the length of the chord which is reducing by each of the units, and as it reduces, ultimately this tends to become, if P tends to Q, then ultimately I get a circle with a line touching the circle at only one point, because here, that is, P becomes equal to Q, and therefore this reduces to one unique point where a line still tries to be on the circle where a line touches the circle. So in this case, I get a secant when a line cuts the circle, but when a line touches the circle, I get a tangent. So we can define the tangent to be a line which touches the circle. So tangent is a line which touches the circle, is how I define the tangent. Any line which touches the circle is called a tangent, and it is derived from a secant where P tends to Q and I get one unique point where the line touches. So when P tends to Q for a secant, I get a tangent. Now let's see some interesting properties for tangent of a circle. Now when I take a circle, I clearly see that there are infinitely many points on the circle, therefore there are infinitely many tangents which I can draw. Etc. So this is how I see that there are infinitely many tangents which I can draw all across the circumference of the circle. Therefore, I can say the first property that infinitely many tangents can be drawn for the circle is how I understand the tangent property for a circle, because circumference has infinitely many points, therefore every point has a tangent, therefore infinitely many tangents which can be drawn for the circle. Now let's connect the tangent with position of a point. Now that we have discussed about position of a point, let's see how we can connect that with the tangent. Now, as we have seen the three different cases of inside, on and outside, I have three cases where if I take a circle, the point can be inside the circle, and then for this I have the point P lying on the circle, and then for this point P is outside the circle. So therefore, in this case of three different cases of inside, on and outside, let's see how the tangent is connected with position of a point. Now when a point is inside the circle, I cannot draw any tangent through P. That means no tangent can be drawn through P x1 y1. But here, as I clearly see, yes, I can draw one tangent through P. That means when a point is on the circle, there's only one unique tangent which I can draw through P. So here it is one tangent, and now from here, for a point outside P, I can draw two tangents, that is tangent 1 and tangent 2, that is two tangents can be drawn through P x1 y1. One tangent can be drawn through P x1 y1. No tangent can be drawn through P x1 y1 is how I understand the position of a point connected with the tangents.